Hi! Today we're going to learn about the alternating series test. Let's say we have a question like this. Does the series from n equals 1 to infinity of -5 times log of n over e to the n power converge or diverge? Well, we know that it's not sufficient enough for a regular series to say, so let's say we had the series from n equals 1 to infinity of log of n over e to the n power. So we know that it's necessary, but it's not sufficient enough. So it's a necessary thing that the limit as n approaches infinity of this sequence approaches 0. So the limit as n approaches infinity of this sequence is 0. So that is necessary for this to be convergent, but it's not sufficient enough to say that this is convergent. However, if we have an alternating series, then it is sufficient enough to say that it is convergent. So an alternating series has a form, the series from k equals 1 to infinity of -1 to the power of k plus 1 times a sub k. So this part is what makes it alternating, so it alternates between negative and positive. And this is the actual sequence. So it is sufficient to say that if the limit as k approaches infinity of a of k, so if the limit as k approaches infinity of a of k is equal to 0, then that implies that the series k equals 1 to infinity of -1 times k, or to the power of k plus 1 of a sub k is convergent. So, once again, if the limit of a of k as k approaches infinity is equal to 0, then that means that this whole series here is convergent. If it doesn't approach 0, then that means that the series is divergent. So, that means that this is necessary and sufficient. So now we have this problem here. We have the series n equals 1 to infinity of -5 log of n over e to the n power, and we have to see if this converges or diverges. So let's isolate this a sub k part. So this should be equal to the series from n equals 1 to infinity of -1 times 5 log n over e to the n power, and this should also be n over here. We should have an n, so -5, so -1, let's just say for simplicity's sake. So we have -1 to the n power times log of n over e to the n power. So that means that this part that encompasses this, so both of these make up a sub k. So we have to see if the limit of this, so because we know this is just a sub k, let's erase everything around it. And we have to see if the limit as n approaches infinity of this a sub k is equal to 0. So it would be log of n over e to the n power. So we know that log of n is about the slowest growing function you can think of other than a constant function. And e to the n power grows pretty fast. So that means that this is probably going to be equal to 0 as n approaches infinity. But let's actually do this to make sure. So here this becomes the limit, so this, if we do simple substitution, or if we just substituted infinity in, we get infinity over infinity. So that means that we have to use L'Hopital's rule, and that gives us 1 over n, which is the derivative of log of n, over e to the n power, the derivative of e to the n. So this is equal to 1 over n e to the n, the limit as n approaches infinity of this, which is equal to 0. So, because this is equal to 0, then that means that this series is convergent. Today we learned about the alternating series test in calculus. Thank you for watching this video.